You ready for some pretty heady stuff today?
Oh, yeah.
We're diving into Erwin Schrödinger's What is Life?
Okay.
A book that's almost 80 years old, but still sparks a ton of debate.
You're not kidding.
And to help me unpack it all,
Yeah.
I've got
I'm excited.
an expert in both physics and biology here with me.
Well, I don't know about expert, but I'm happy to dive in.
Yeah. So what makes this book so fascinating?
Well, I think one of the things is that Schrödinger,
Yeah.
a Nobel-winning physicist,
Right.
jumps right into biology,
Wow.
asking this big question: can physics explain life?
And he starts in a total unexpected place, right?
Totally, with the size of atoms?
Yeah, that's not your typical biology 101.
Nope.
So how does the size of an atom relate to, well, us?
That's a great question.
Yeah.
Schrödinger argues that life needs a certain scale to function,
Okay.
like to work reliably.
Got it.
Physics and chemistry,
Mm-hmm.
they're statistical.
Okay.
They rely on massive numbers.
Yeah. Of atoms and molecules to kind of average out the chaos.
So we're not talking about single atoms
Really?
doing their own thing,
No.
but huge groups behaving predictably.
Exactly. Like, think of it this way.
Okay.
Schrödinger had this rule,
Yep.
the sun rule.
Okay.
Basically, it says the more molecules you have,
Yeah,
the more accurate
right.
the laws of physics become.
So the more, the merrier.
You got it. Now
Okay.
imagine a tiny little boat in a hurricane.
Oh, man.
That's what life would be like.
Yeah.
If we were only sensitive to individual atoms.
Wow. That's kind of a scary thought.
It is.
Our senses all messed up.
But told her.
Our body's just, like, malfunctioning.
Yeah, chaos. So the statistical stability,
Right.
it's the bedrock for life to even exist.
Makes sense.
Right.
Yeah.
It allows for the complexity and the order we
Totally.
see in living systems.
So everything from our senses
Mhm.
to, like, how our brains work
All of it.
depends on those laws.
Yeah. Of physics working smoothly.
Exactly.
That's a pretty profound thought, right?
It really is, yeah.
Makes you appreciate the sheer scale
Right.
of things needed for life to function.
Absolutely.
But Schrödinger doesn't stop there.
He does not.
He goes on to heredity.
That's right, the chromosome.
Yeah.
He was blown away by how this tiny structure
Uh-huh.
could contain the entire blueprint for an organism.
It's like this super efficient code
Totally.
for building and running a whole being.
Absolutely. And don't forget,
Yeah.
every single cell in your body has this code.
That's wild when you think about it. This
Oh.
tiny thing
Yeah.
orchestrating everything.
I know, it's incredible.
From hair color to our organs.
Yeah.
Schrödinger called it.
I love this quote.
What'd he say?
He called it an architect's plan and builder's craft in one.
He wasn't kidding.
He was not exaggerating.
And he also realized that this code,
Yeah.
it wasn't just static, right?
Right.
It could change.
He dives into mutations,
Okay.
sudden changes in the hereditary code.
So he's not just talking about inheritance,
So-
but also how life changes and adapts.
Yes, exactly. And he even calls mutations
What does he call them?
the quantum theory of biology.
Wow, that's a bold statement.
Right. He saw mutations as these jumps in the code,
Okay.
contrasting with Darwin's ideas of gradual variations.
Interesting.
So Schrödinger's arguing these leaps are the raw material
Yeah.
for natural selection to work with.
Driving evolution.
Exactly.
And what's amazing is he's writing all these
yeah.
decades before we discover DNA.
I know.
It's like he's hinting at
Mhm.
these changes happening at the molecular level.
He was way ahead of his time.
He was. But it leads to another question, right?
Definitely.
How can something so small,
Yeah.
like a gene, be so stable
Right.
and hold so much information?
Especially given all that chaotic atomic movement we talked about.
Exactly. Like, how can this tiny structure
Yeah.
withstand all that
Yeah.
and still function so reliably?
So that's where he brings in
What does he bring in?
quantum mechanics.
Okay.
He realized that classical physics
Mm-hmm.
couldn't explain the stability of genes.
Right, because those statistical laws break down
Exactly.
at very small scales.
He's suggesting there's something else going on
Okay.
at the quantum level
Right.
that allows those few atoms in a gene to hold their structure.
So it's like a whole different set of rules down there
Pretty much. Yeah.
governing how genes function.
He points to the Heitler-London theory
Okay.
of chemical bonding,
Okay.
a quantum theory,
Uh-huh.
explaining how atoms share electrons to form stable molecules.
Got it. So he's saying this is key to understanding
I think so, yeah.
how genes, as molecules, maintain their integrity
Yeah,
and carry information across generations.
that's the idea.
Okay, so I'm starting to see how he's connecting these levels.
Yeah.
From atoms to genes to traits.
It's pretty amazing, right?
It is, but what about those sudden changes?
The mutations.
Yeah, how do those happen?
Well, that's where isomeric molecules come in.
Okay, and what are those?
They're molecules with the same atoms,
Okay,
but arranged differently.
so like rearranging letters in a word to make a new word.
Exactly. And Schrödinger proposes
Yeah.
that mutations could involve these kinds of transitions
Interesting.
within the gene molecule.
Okay, so we're talking about events
Mm-hmm.
happening at the atomic level
Yeah,
that can have huge effects on an organism.
right. But to really understand this miniature code,
Right, how it all fits in this tiny structure.
we need to bring in Max Delbruck's work.
Okay, and what did he do?
Delbruck proposed this model of the gene
Uh-huh.
as an aperiodic crystal.
Periodic crystal.
It's highly ordered, like a crystal,
Mm-hmm.
but its pattern doesn't repeat,
Okay.
which lets it store a ton of information.
So it's like a tiny,
Yeah,
super complex blueprint packed with information.
exactly. Think of Morse code.
Okay, yeah.
Limited symbols, but endless combinations.
Right.
Right.
So it's like a tiny blueprint
Yeah.
for life itself.
But then there's another big question
Oh, yeah.
that Schrödinger tackles.
What's that?
The question of entropy.
Okay.
How do living things,
Mm-hmm.
these super-ordered, complex beings,
Yeah.
seem to defy the tendency towards disorder?
That's where things get really interesting.
Okay.
He suggests that organisms
Yeah.
don't actually violate the laws of physics.
Okay.
We just haven't fully grasped how they're working.
Got it.
He proposes that living things maintain order
Hmm.
by extracting what he calls negative entropy,
Negative entropy.
basically orderliness
Right.
from their environment.
So it's like we're constantly taking, in order to funk the disorder we create just by living,
It's a remarkable balancing act.
mind-bending stuff. But where does this negative entropy come from?
Well, Schrödinger thinks
Hmm.
it comes from the food we eat.
Okay.
Animals consume complex compounds
Mhm.
full of order
Right.
and break them down. Okay.
Releasing them in a more degraded form.
So we're literally feeding on order,
It's like our bodies are entropy fighting machines.
constantly taking in order
Exactly.
and expelling disorder.
Yeah. And that leads Schrödinger to this
Yeah.
really bold conclusion.
What's that?
Life probably involves other laws of physics.
Hold on, new laws of physics.
Yeah.
That sounds a bit out there, doesn't it?
I can see why you'd say that.
Is he suggesting some mystical life force?
Not at all.
Okay.
Think of it this way.
Okay.
Imagine an engineer who only knows about steam engines.
Right.
And then they see an electric motor for the first time.
Okay.
Both are made of similar materials, right?
Hmm.
But they operate on totally different principles.
I see what you're getting at.
Mm-hmm.
He's not denying the laws of physics,
Right.
but suggesting that life might be using those laws in a way
Yeah.
that we haven't quite figured out yet.
There's another layer of complexity.
Got it.
A whole other set of rules governing living systems.
Yeah. So he's saying life operates more dynamically,
Yeah.
using existing order to create more order.
Instead of just relying on statistical averaging.
It's like a chain reaction of order,
Yeah.
starting from the chromosome
Mm,
and extending outward to the whole organism.
exactly. It's a fascinating idea, but
Hmm.
didn't some scientists push back on that?
Yeah, suggesting new laws of physics for life
Right.
seems pretty controversial.
Oh, yeah.
They say.
Well, some felt that Schrödinger
Yeah.
was overstepping as a physicist, you know?
Oh, like he was stepping on the biologist's toes?
Yeah,
Thinking he could just waltz into biology
Right.
without fully understanding it.
But a lot of people were excited by his ideas.
So even though he came from physics,
Yeah.
he had a big impact on biology.
Huge.
Yeah.
Well, his book helped pave the way for molecular biology,
Oh, wow.
which totally revolutionized our understanding of life.
And that's still a major field today.
Absolutely. His work's relevant for things like synthetic biology.
Trying to create artificial life.
Exactly.
Wow.
And the search for extraterrestrial life, too.
Oh, yeah.
We might encounter life that operates on totally different principles.
It's amazing that a book written so long ago
I know, right?
is still shaping cutting-edge science.
It is. But Schrödinger didn't just focus on the science.
What else?
He also got into the philosophical side of things.
Oh, like what?
Like the question of free will.
Okay.
He realized
Yeah.
if life is just a complex machine governed by laws,
Mm-hmm.
how can we have free will?
That's a big question.
It's been bugging philosophers for centuries.
Yeah, because on one hand,
Yeah.
we feel like we make choices.
Right.
we're in control,
Yeah.
but our bodies and brains are just atoms and molecules obeying the laws of physics.
That's a tough one.
It is. How did Schrödinger tackle that?
Well, he brought in ideas from Eastern philosophy,
Like what?
Vedanta,
Okay.
which emphasizes this unity of consciousness.
Okay.
He suggests that consciousness might not come from the brain,
Whoa.
but is a fundamental part of reality itself.
So it's like our brains are tapping into a universal consciousness.
That already exists, yeah.
That's a pretty radical idea,
It is, and it sparked a lot of debate.
because it challenges the whole idea that the mind is just a product of the brain.
Exactly. But it also raises more questions.
Right.
Like, if consciousness is fundamental,
Yeah.
where does it come from?
Right.
How does it interact with the physical world?
Those are big questions.
Huge ones.
That scientists and philosophers are still working on.
Definitely.
But I think it shows how Schrödinger
Yeah.
was willing to explore these deep questions.
Alongside the science,
Yeah.
it's a testament to his desire
Yeah.
to understand life in all its complexity.
He was really pushing the boundaries,
Oh, absolutely.
connecting physics, biology, philosophy.
In a way that no one had done before.
And his work still inspires us
Totally.
to ask those big fundamental questions about life and the universe.
And everything.
You know, one thing that strikes me is
Right.
how Schrödinger explains these complex ideas so clearly.
I know, right?
Like, he uses these vivid analogies
Sorry?
that
Yeah.
make even the most abstract concepts relatable.
He was a master communicator.
And that's why What is Life is still such a popular book.
Absolutely. It's not just a science textbook
It's something anyone can read and enjoy.
and learn from.
It's had a huge influence on other scientists, too.
Oh, for sure.
Like Francis Crick.
One of the guys who discovered DNA.
He said, "What is life?" played a role in his thinking about biology.
It's pretty remarkable
Yeah.
that a book written before DNA's structure was known
Yeah.
could have such a big impact on genetics.
It shows the power of asking the right questions.
I agree.
And Schrödinger, coming from physics,
Yeah.
could see beyond the details of biology to the underlying principles.
And he wasn't afraid to speculate either,
Right.
to put forward bold ideas that could be tested later.
He set the stage for so many discoveries.
Absolutely. But we have to remember
What?
the historical context, right?
Oh, right.
He was writing right after World War II,
Okay.
a time of huge uncertainty.
Yeah.
There was this feeling that science needed a new direction.
To use its knowledge for good.
Exactly.
So, What is Life was also a call to action,
I think so, yeah.
challenging scientists to use their knowledge.
To solve humanity's biggest mysteries.
And that's still relevant today.
Totally.
Yeah.
We're still grappling with those questions.
Yeah.
How did life begin?
Right.
What is consciousness?
Are there limits to what we can know?
All these big questions.
It's humbling to realize how much we still don't know.
It is,
Yeah.
but we're making progress.
Yeah, we're constantly discovering new things.
Yeah, about life, from molecules to ecosystems.
And with each new discovery
We're getting closer to a deeper understanding.
of what it means to be alive, how life even began.
Our place in this web of existence.
So, for you listening, what can you take away from all this?
Keep exploring.
Yeah, the quest to understand life.
It's an adventure
It's a journey of asking questions,
picking answers.
even when those answers lead to more questions.
Be open to new ideas. Connect the dots. Challenge assumptions.
Like Schrödinger did.
Exactly.
He was a true pioneer
A visionary.
who dared to ask the big questions.
And help to shape the way we think about life itself.
His legacy continues to inspire us.
So keep exploring.
Keep questioning, keep diving deep.
Who knows what discoveries are waiting for us?
Beautifully put.
Thanks.
That brings us to the end of our deep dive
Oh,
into What is Life.
I hope you enjoyed it.
We hope you enjoyed it.
Yeah.
And if you want to learn more,
Pick up a copy of Schrödinger's book.
it's a timeless classic.
It really is.
And share your thoughts with us.
What resonated with you?
What questions are you pondering?
We'd love to hear from you.
Until next time, keep those minds curious.
And those questions flowing.
There's a whole universe of wonder out there.
Just waiting to be explored.
And who knows? Maybe you'll be the one to unlock.
The next big secret of life.
We'll see you next time.
He thinks it comes from the food we eat.
Okay.
Animals consume these complex organic compounds.
Right, full of order.
Exactly.
And break them down,
Yeah.
releasing them in a simpler form.
More degraded, less ordered.
So we're literally feeding on order.
It's like our bodies are these incredibly efficient machines
Yeah.
fighting against entropy.
Taking in order
Yep.
and expelling disorder.
It's amazing. And it leads Schrödinger to a pretty bold conclusion.
Oh.
He thinks life must involve other laws of physics.
Wait, new laws of physics?
Yeah.
Isn't that a bit far out?
I know, but hear him out.
Okay.
He compares it to like an engineer
Yeah.
who only knows about steam engines.
Okay.
And then suddenly they encounter an electric motor.
Oh.
Both are made of similar materials, but
Yeah.
they operate on totally different principles.
So he's not saying the laws of physics are wrong.
No, not at all.
Just that life might be using them in a way that we haven't fully figured out yet.
Exactly. Like there's another layer of complexity.
Okay.
Another set of rules that govern these living systems.
Right. So he's saying life operates more dynamically.
Exactly.
It uses existing order to create even more order.
Yeah, it's not just relying on statistical averaging.
More like a chain reaction of order.
I like that.
Starting from the chromosome
Right.
and extending outwards.
That's the entire organism.
It's a pretty mind-blowing concept.
It is.
But didn't some scientists push back on this?
Oh, yeah, of course.
Suggesting new laws of physics for life?
Right. That's a big claim.
What did they say?
Well, some of them felt that Schrödinger
Yeah.
was kind of overstepping,
Oh, like a physicist coming into biology
Exactly.
and telling them how things work.
Yeah, like he didn't fully understand the intricacies.
Right.
But a lot of scientists were actually excited by his ideas.
Really?
Oh, yeah. His book really helped pave the way for molecular biology.
Wow. Which is still huge today.
Absolutely.
Yeah.
And his work is relevant to like synthetic biology.
Creating artificial life.
Exactly.
Incredible.
And the search for extraterrestrial life, too.
Oh, right.
You might encounter life that operates on completely different principles.
It's amazing to think
I know.
that a book written so long ago
Yeah,
could still be shaping cutting-edge science today.
it really is. But it's interesting.
Right.
Schrödinger didn't just focus on the science.
Oh, what else did he talk about?
He delved into some philosophical questions, too.
Like what?
Like free will.
Free will.
Yeah, he realized
Yeah.
if life is just this complex machine
Mm-hmm.
governed by deterministic laws,
Okay.
how can we possibly have free will?
Yeah, that's a question that's been around forever.
I know. It's like, on one hand,
Yeah.
we feel like we make choices.
Right, we're in control.
But on the other hand,
Yeah.
our bodies, our brains,
Yeah.
it's all just atoms and molecules.
Obeying the laws of physics.
It's a tough one.
It is. How did Schrödinger approach this?
Well, he actually brought in ideas from Eastern philosophy,
Oh, really? Like what?
like Vedanta,
Okay.
which emphasizes the unity of consciousness.
Okay.
He suggests that consciousness might not even come from the brain,
Whoa.
but is actually a fundamental part of reality.
So, like, our brains are tapping into this universal consciousness.
That already exists, yeah.
That's a pretty radical idea.
It is, and it's caused a lot of debate.
Yeah, I can imagine.
It really challenges the traditional view
Yeah.
that the mind is simply a product of the brain.
Right. But it also raises more questions.
Of course.
Like, if consciousness is fundamental,
Mhm.
where does it come from?
Exactly.
How does it interact with the physical world?
Those are the big mysteries, right?
Huge mysteries.
That scientists and philosophers are still trying to figure out.
But it shows how Schrödinger
Yeah.
was willing to explore these really deep philosophical questions.
Alongside the scientific ones.
It shows his desire to understand life in all its complexity.
Absolutely.
He really was pushing the boundary
Oh, yeah. He was connecting
Yeah.
physics, biology, and philosophy.
in a way that no one had really done before.
Right.
And his work is still inspiring us today
Totally.
to ask those big questions.
About life, the universe, and everything.
You know, one thing that always strikes me about Schrödinger
Yeah.
is his ability to explain these really complex ideas.
I know.
So clearly.
He was such a good communicator.
Right. He uses these vivid analogies
Yes.
that make these abstract concepts feel relatable.
I think that's why What is Life is still so popular.
It's not just a dense scientific book.
Right. It's something anyone can pick up.
And find thought-provoking.
Exactly. And it's influenced so many other scientists, too.
Ah, for sure, like Francis Crick.
Yeah. One of the guys who discovered DNA.
He even said that what is life?
Really?
Yeah, he said it influenced his thinking about biology.
Wow, that's amazing.
It really is.
Think about it.
Yeah.
A book written before we even knew DNA's structure.
Could have such a big impact on genetics.
It just shows the power of asking the right questions.
I agree.
And Schrödinger,
Coming from physics,
yeah,
he was able to see beyond the details of biology.
to the underlying principle.
Exactly. And he wasn't afraid to speculate.
He put forward these bold ideas
that could be tested by later research.
He set the stage for so many discoveries.
Absolutely. But it's important to remember
What?
the historical context.
Right.
He was writing just after World War II.
A time of huge uncertainty.
Exactly.
And there was this feeling that science needed a new direction.
To use its knowledge for good.
So what is life? Was kind of a call to action.
I think so, yeah.
Challenging scientists to solve humanity's biggest mysteries.
Exactly. And you know what?
What?
That challenge is still relevant today.
Because we're still grappling with these same questions.
How did life begin?
What is consciousness?
Are there limits to our knowledge?
All these huge questions.
It can feel humbling, right?
It really does. To realize how much we still don't know.
But we're making progress.
Absolutely. We're constantly making these new discoveries.
About life, from molecules to ecosystems.
And with each new discovery, we're getting closer.
Closer to understanding what it means to be alive.
Understanding how life began.
And our place in this vast web of existence.
It's amazing.
It really is.
So, for everyone listening,
Yeah.
what can you take away from all this?
The quest to understand life,
It never ends.
it's a journey of exploration.
Asking questions, seeking answers.
Even when those answers lead to more questions.
Exactly. Be open to new ideas, connect the dots.
Like Schrödinger did.
Challenge your assumptions about how the world works.
He was a true pioneer
A visionary.
who wasn't afraid to ask the big questions.
He really shaped the way we think about life.
And his legacy continues to inspire us.
Totally. So keep exploring.
Keep asking questions. Keep seeking answers.
And don't be afraid when those answers lead to even more questions.
That's part of the fun, right?
It is, yeah. Be open to new ideas. Make connections.
Think outside the box.
Challenge what you think you know about the world.
Just like Schrödinger did.
He really was a pioneer.
A visionary who wasn't afraid to tackle the big stuff.
He changed how we think about life.
And his work is still inspiring us today.
It's amazing.
So, we've come to the end of our deep dive
Already.
into what is life.
It's been a wild ride.
I know, right?
Full of big ideas.
We hope you've enjoyed exploring these mind-bending ideas with us.
I hope so too. And if you really want to dig in,
Yeah.
pick up a copy of Schrödinger's book.
It's a classic for a reason. It really is. And be sure to share your thoughts with us.
Yeah, we'd love to hear what resonated with you.
What questions are you still pondering?
Hit us up on social media.
Until next time, keep those minds curious.
And keep those questions flowing.
There's a whole universe of wonder out there waiting to be explored.
And hey,
Yeah.
maybe you'll be the one to unlock.
The next big secret of life.
It could happen.
We'll see you next time.